Alright, hello year 10. So while you are doing the listening, retake, and some students are helping here, we are going to do the new topic. The new topic is Venn diagrams. Venn diagrams, they represent sets. So for example, here A can be, let's say, students that they like math. B can be students that like ICT. So for example, the intersection, because the name of this thing, this symbol is intersection, will mean the students that they like math and ICT. This big U is for union. Let's say A is students that they like math, B is students that they like ICT. So all these painted groups are students that they like either math or ICT or both. Now, here you can see everything is painted, and what we paint outside means that these students, they either don't like math or they don't like ICT. So we have, again, A, students that they like math, B, students that they like ICT. You got the intersection, you got the union, and this apostrophe here, this little line, represents that we are not going to count this part. We are going to see it deeply more forward. But in other words, if we have A with this little apostrophe, it's called a complement. So for example, here A complement is like all the students that they don't like math will mean these ones outside. Now, as I was saying before, here we have another Venn diagram. This Venn diagram, for example, represents students that they like PE, students that they like English, students that like biology. And here we can represent them with this NE. NE is the number of elements. So E is the number of elements in E, which means students that they like English. For example, here the total of students that they like English is 42. But some students, they only like English. Other students, they like English and PE, which is 8. Other students, they like English and biology, which is 4. Other students, they like PE and biology, which is 7. And lastly, we have students that they like all of them, which is 2. Now, to represent all of these, I'm going to show you in the board. Let's say I want to represent the number of students that they like PE and biology. So we write it in the following way. The number of elements of students that they like PE, so we have P for PE. It's only one letter. And biology, we are going to use the letter B. So you see the total of students will be 2 and 7, 9. Now this is going to be an intersection, because remember, if we paint this, it's going to look like the intersection here. So in that way, we can represent that we have students that they like PE and biology. Also, let's consider that students that they like the 3 subjects, they like PE and biology also at the same time. So that's why we take in account the number 2. If I want to represent the students that they like all the subjects, it will be the number of students that they like PE, biology, and English, which is only 2 students. Now, you see this number 10 outside means the number of students that they don't like any of those subjects. We can represent them like this. We can put N none, okay, like to make it short, none represents they don't like none of the subjects, which in this case is 10. Well, we also have the U, which means the universe. The universe means all the students all together. So we will have to add 28 plus 4 plus 18, etc., etc. And the total of the students of the universe, counting also these ones that they are outside, is 120, which is the total. So let's continue with this reasoning problem. In the following reasoning problem, we have the following. We have a market research company which surveys 100 students. Okay, so the number of the universe is 100 students. 75 of them own a television, so we can say the number of elements they have a television, 75. And the number that they have a bicycle, it will be NB. It's 45. So in this case, we are going to represent it with the number of people they have television, the number of people they have bicycle, and 35 students that they have both. So that will be the ones that they have television and bicycle, which is 35. If we want to represent that in a diagram, in a Venn diagram, we will have things like this. For example, we are going to have two circles. Sorry for that. We will have two circles, one like this, the other one like that. We will have the ones they have television, the ones they have bicycle. You can see that also we will have students, they either don't have a television or a bicycle, so they are going to be students out this. Okay? Now, if we try to fill this Venn diagram, we are going to have television, bicycle, and we are going to start with the students they have both. The students they have both is 35. 35 students they have both television and bicycle. Now, students they have bicycle is 45, but they also, we are counting the ones they have television. So 45 minus 35 will be 10. So here you will see the students they have bicycle is 35 plus 10, 45, which is the result here. The students they have television is 75, so 75 minus 35 is 40. 40 plus 35 is 75, so 75 students they have television only. And to finish, we have also students outside here. Here we don't know how many students they don't have either bicycle or television. So if we have a total of 100 students, which is the universe, and we subtract the ones they have television, the ones they have television and bicycle, and the ones they have bicycle, we will have 60. 60 minus 35 is 25, minus 10 is 15. So 15 students, they don't have any of that. So to answer these questions, find how many students own either a television or a bicycle or both. So to answer the first question, we will have to add 40 plus 35 plus 10, which will be, in this case, 85. 85 students, they either have only television, only bicycle, or both. For the big one, find how many own neither a television or not a bicycle. So that is easy. The ones that are outside, 15 students, they don't have any of those. Explain your diagram shows that 50 students own either a television or a bicycle, but not both. Okay, so in C it says 50 students, they have either a television or either a bicycle, So we have 40 plus 10. But they don't have both. Okay, so 50 students, they only have television, here only 40, or only bicycle, that you can see here. So in the diagram you see we have 40 with only television and 10 with only bicycle, which gives me a total of 50 students. So the correct explanation will be 40 students, they only have television, and 10 students, they only have bicycle or a bike. Okay, that is for today. The next class we are going to do problem with asteroids. Okay, so be prepared for that.